so today's podcast has to do with density. And density is one of those things you probably talked about a little bit or seen in another science class. And density has to do with how much mass is in a certain amount of space. Alright? So density, just as an equation, density equals mass over volume. Right? I'm just going to spell this out. Mass over the volume. And volume can really be taken two different ways. We can either have a nice shaped object that has a nice length, width, and height, and that's volume, or it might be an irregularly shaped object. Alright? So if it doesn't, then it's really hard to get its length, width, and volume. We can also might have spheres. In spheres we can get the volume of fairly easily, 4/3 pi r cubed. But volume is typically 3 dimensions, so it's usually a cubic measurement. So oftentimes it'll either be square, cubed, meters cubed, or centimeters cubed. And there is a relationship, you've seen this before, but a cubic centimeter, so that would be a box that's a centimeter by a centimeter by a centimeter, is the same volume as a milliliter. Alright? So we can talk about volume two different ways. Either liquids, usually measure them with milliliters, or a cubic centimeter. But either way, it's a length, width, height. Alright? So, we might say, what happens if you had something that was 16 grams, right? And it had a volume, or maybe it's a box, so we're just going to draw a box real quick, and its dimensions are, let's say, 2.0 centimeters, and its depth is 2.0 centimeters, and its height, this is not necessarily to scale, let's say its height is 1.0 centimeters. Alright? So if density is mass over volume, and we have a nice regular shaped object like this, we're going to have 16 grams divided by, really, length times width times height. So we're going to have 2 times 2 times 1. Alright? So we're really going to have 16 divided by 2 twice, or 2 times 2 is 4, so 16 divided by 4 is 4. And because it's significant figures, because we're multiplying and dividing, 16 has 2, 2.0 has 2, 2.0 has 2, 1.0 has 2. So really our answer is going to be 4.0. And then our units are going to be grams over cubic centimeters. Okay? The other way we could do this is, let's say we had some kind of irregularly shaped object, and let's still call it 16 grams. But now, it's just kind of a big rocky blob, okay? So there it is. How can we get the volume of that? Well, what we can do is we can have a graduated cylinder. Alright? Looks more like a flask or something than a graduated cylinder. Alright? And we can put some water in there. So I'm just going to put a little bit of blue water in here. Alright? And we can look at its volume before we put the rock in. Alright? And its volume, let's say, is at 10.2 milliliters. Okay? And now what we're going to do is we're going to insert this rock. Okay? So the rock goes in here, and now it's going to be, I draw it again, there it is. What happens when we put a rock in the water? Well, the water level is going to rise, okay, because this rock is taking up a certain amount of space. So whatever space it's taking up is going to cause the water level to rise a certain amount. So now our water level goes up that high because that water displaces some of that water. Alright, and now we look at it, and let's say our volume is now, I don't know, let's say 18.9 milliliters. Alright, so if we take the difference of these two numbers, we're going to find it's 8.7 milliliters. But again, milliliters tells us volume just like cubic centimeters does. So what I can do is mathematically, I can take 16 grams and divide that by 8.7 milliliters. And I'm going to get some value, I'm not sure what it is this time, a little bit less than 2. Alright, so we're going to get 1.8, and then we're going to stop there because we have two significant figures, 1.8 grams per milliliter. Okay? So again, density, two different ways we can do this. If we have a regularly shaped object, we can get its volume. That's typically length times width times height. and it's mass over volume either way. If we have an irregularly shaped object, we're going to use something like a graduated cylinder, a beaker, a flask, put some water in it. Some level that's above the level of our irregular shaped object. Put the object in there, the water's going to be displaced, it's going to go up, and find the difference. And we can find out how much space that thing took up. But either way, density, mass over volume, easy to solve.